So hello, welcome in my next video. This video will be a little bit different as the others, but first of all I have to introduce, I would like to introduce you. This one is out, we just put it out from the scene. And here we have a very specific tool which I asked many years ago. I asked my friend to create, to weld this, let's say, creature, and in that time I didn't know that for what is the creature, but currently I really recovered it from a heap of scrap in my bottom pit. Bottom pit is something like, now we are in the pit, and under this pit there is small bottom pit. I call it like bottom pit, like something like secondary pit, which is even deeper, but it's very small. But it's good to leave the things which are considered to be scraps. You see that color is a little bit, I just brush it out, but I need to repaint it a little bit because the color and everything is in not a good conditions. And especially inside there is rust, very deep rust, and this will be this is gonna be the video about how to anti-rust it. I'm going to use this chemistry which I prepared from basically I don't know that if it's A2SO4. I don't know what kind of acid, but this is chemical, internationally recognized chemical pattern, or how to call it. And it could be also like citric acid. I think that citric acid is this Kyselina citronova citric acid. It is like pentahydrate something of something, I don't know exactly, but the problem is that you could see that at the bottom there is still a solid state, and I had just solid state in a tube or in a dose which wasn't recognizable that what's inside. So according to dose, basically it should be citric acid, but I'm not sure if it's citric acid. But anyway, it doesn't matter. Both of them can clean the rust by disappearing the rust. And therefore I'm in the pit, because to operate with this citric is quite dangerous, and you never know what's gonna be the reaction, because we need to use very high concentration of this citric acid, so we never know that what could happen. Therefore we are in the pit. So I need to put gloves on my hands, and we can go on. We will do it very simply, and we have safety savage here, so if something is like going out of control, we are able to react. So, and basically we can start. Okay, let's put the second glove. We can start with our cleaning process. So it's enough. Okay, here we have warm water, and we will do it like this way. This part is enclosed. We have just here something what we can, we pour a little bit water at first, not just put concentrated acid, then we put problem. Be careful on clothes, because this, if it's H2SO4, it's damaging to your clothes. Okay, it's enough. it's a little bit reactive inside. Never mind. It should be like this way. We don't need to seal it because, and we will just shake it in a little bit different directions. The aim is to, let's say, disattach the particles which can be disattached by the water, because following test will be basically I will use this system as a pressurized system. Since I have here a prepared valve for pressurizing the system, and here I put here I will install the testing object. Basically it is very cheap kind of valves which I'm buying from AliExpress, but I've never been testing this, if it's really durable and how much pressure it can prove, or it can persist. This is very important for me because the elements are really cheap against the other. In our country, the same valves, those are basically not ball valves. Even the system is different. It's China's. It's something like like flange. I would like to say it's close to flange valve, but it is even not flange valve. It is something like the two particles, and there are triangles, and if triangles are overlapped, then there are holes, and if they are not overlapped, they are not holes, and it is like this way. Okay, so we will try to put it out. I would like to capture a little bit. That was gonna be the outside. That's gonna be the solution. Maybe you saw that there was a little bit rust, but not so much. But it's still ongoing chemical process there. But I forgotten one thing. I forgotten to put there this very important thing. Okay, this camera is really shit because it's like that. I forgotten to put there detergent, saponate or detergent, because this can release, if there is fat, this acid is oh my god, nothing is visible now. Okay, if there is a fat, there is no let's say, this acid is fat resistant, let's say, or not very keen to dissolve the fat elements inside, and there could be of course fat elements. So I will repeat the experiment with implementing also common detergent for washing the glasses or washing your washing, basically, yes. And I will try to shake. Okay, then I will go with my camera here. Okay, but water is much better now, so I think that it's almost stabilized. Now I need to neutralize it. Yeah, to be neutralized. Yeah, somehow like this way. more time. Okay, one more time. Maybe a couple of more times, because when there is even small rest of the acid, it can make big damages, and I don't want to lose this. Okay, there. Okay, the preparation is well done. Okay, and so we have prepared the testing tool. I'm going to camera is also out of. I'm going to bring some other tools, and in order to install the valve, the testing object, and then I will continue with the video. I have fortune because I found it very easily. Basically, maybe some of you already know it. It's made from stainless steel 304. It means that it is lower quality steel, but still enough to be anti-rust. And inside the package there is such a valve, and although in each package unfortunately sometimes damaged by manipulation, is such a aesthetical ring, but it is from aluminium, polished aluminium, but as you can see that sometimes is a little bit damaged, but as it was damaged, as the same way very easily we can debend it or deflect it back into original position. So sometimes or very often you can modulate it back to be shown nicely, but it is not currently our intent. Our intent is to install this valve into this half-inch position. So first of all I will try to that can be a little bit problem after. Okay, this is too poor. This I can break it very easily. I will use different tooling. I hope that there is something visible. And there is almost nothing visible. Yes, because it's like that. Okay. So this was really tough. Because these adjustable wrenches are not very tough, we can wrap the jaws very easily. Therefore I will try to be always very careful. Okay, don't put fingers inside because there is still residue of the acid, but for our testing purpose it's not so important. We are going to install this valve here, and basically the aim of the test is to prove when the valve is closed that it can persist the pressure. Basically how I will measure the pressure, I have two ways. The first way Okay, it's not visible again. The first way is that I will connect directly here in this common valve. This is the first way. How can I measure the pressure? Or the second way to measure it will be that I will install manometer here. I will install a splitting point and like T connection, and on one side of T connection I can install a manometer. But problem, or theoretically it is not necessary to do it in such a way, because I will have liquid here, and basically if this valve is not sealing enoughly, the leakage of the liquid will be visible, or would be visible, yes. So because I will bend all the system in a such let's say angle that here will be air, but here will be liquid. So the final bending will be somehow like, let's say, this. I don't want to do it absolutely, because there is still water. I need to refresh the water maybe to be okay. I can also clean the water now. I'm going to clean it and then I'll be back. But basically, because of there will be water and only small capsule of the air to have a certain pressure, or to moderate the pressure over this capsule, air capsule. Because if you don't have air capsule inside the system, you are unable to moderate small pressures like a couple of bars. You can moderate the pressures in which the water is compressed, but we are talking about pressures which are used mainly for water jet streams, like for water lasers, maybe you call it water jets or water lasers, for cutting the materials. There are extreme pressures, couple of hundreds of megapascals, I think. So simply said, really extreme pressures. And in these pressures, the water, because water has also oxygen inside, and basically it's hydrogen and oxygen, but there are also ions, and these ions are only not binded elements. And if the ions are compressible, so you can really compress the water. Like if you have CO2 in the water, you can compress the small bubbles to be even smaller, and then even smaller, and etc. etc. So, and you always have something like this because you never use purified water for laser jet cutting. Yeah, but for our testing purpose, we can consider that water is not compressible. So therefore we need to leave a small, such a maybe 10 centimeters air capsule, or maybe a little bit bigger air capsule, I don't know, to be able to moderate a little bit like the pressure inside. Yes, we can also leave in a bigger capsule. So I'm going to reclean this, and then I'll be back. Okay, it is done. So now I'm going to install this valve. There are certain rules for installing or correct installing the valve. The first of all, very primary to installation, we need to make this very nicely polished thread to be a little bit rough, or more rougher. I don't know if rougher is correct, and I will use it. It's very okay. I can demonstrate it here, because here I have also some base too. But it is very tough material, because it's stainless, and it's almost impossible to make it luster. Yes, good. Good. When we feel that it's a little bit rust, it's enough. The second thing is that we need some other material. This one, okay, we will use this one, and also this one. Is it visible here? No, it's not visible, this one. So I will start with this one material, but I need two hands, and it's very, what is visible? Okay, here is visible, this space. So I can use like this way, just to be visible what I'm doing. Basically, this rope is too thick. I need just a thinner one, so I will just split a little bit. These gloves are not very convenient because those are sticky. I have to use different gloves, or if no gloves, no different gloves. Okay, this should be much better, maybe. No, they are not better. I don't think so that they are better because I have no sensitivity in them. So finally, I have to operate without gloves, and it's very simple. We just make a teeny starting point, and then not from very edge, because now it's not important, because now there is only a matter of testing. But when you go very close to edge, by pressing and mounting, the rope will be out of the edge and will be going inside the valve. So a little bit, if you have big thread like here, this is very good. Am I in the video? That the thread is very or longer, like usually you have 2/3 of this size. This I have to commendate China's engineering, because this is very convenient. I'm talking and not concentrating what I'm doing. So basically, if you have bigger thread, you can miss 2 or 3. 2 is enough. 2 is enough. At least 2 revolutions, or how to call it correctly, because revolutions are this is like our direct translation, probably not correct in English, doesn't have any sense, but it doesn't matter. And also we can leave the rest, so I will just cut off like here. Then this is very first step. Then there is something what I call liquid Teflon. Liquid Teflon is very dangerous on your skin, because it can dissolve the fats. So it means that it can penetrate very easily through your skin into your body, and it is very high carcinogen. Unfortunately, nobody tells you this true, but be careful in working with liquid Teflon. It is like mercury, like to work with mercury without gloves. So, and here yesterday I contaminated very, very deeply with liquid Teflon. Okay, but I need really to concentrate even now. And now here is the Teflon tape. Teflon tape is used just to cover the liquid Teflon and to a little bit compress it. And okay, I contaminated again. Okay, I need to be very careful what I'm touching now, because I don't know if it's visible something, but I need to do it like to concentrate. Okay, I was too brutal. Never mind, we can. Okay, come on. And what's happening inside? The liquid Teflon will be combined with the stabilized Teflon tape, all together, and will create such a perfect sticky material that the same sticky material was used here, and you could see that how big force I had to need to disassemble it. So it means that assembling is not a problem at all. It's not a problem, but disassembling is a problem, and this is the reason that liquid Teflon is it's much easier to install it once the liquid Teflon is hardened, you don't need you don't be worried about that you are touching, because it becomes from liquid phase when the dissolvers are disappeared sometimes into the water. Be careful also when you are drinking from such installation. There is certain something like a safety period that you are not allowed to use this water for cooking or drinking, for consuming, even for animals, because it goes also through the animals to you. Okay, and what liquid Teflon helps you to install it literally by hands, yes, literally by hands, but I need gloves because to put the gloves on my hands. But it is not so absolutely literally maybe, but it's almost literally. And I found some tools like this tool, maybe this tool. You know what I help, how can I help with this tool? Nothing. It's not helping me. But another tool can help me. We have here such a, let's say, installation help tool, but never use only this touching, always use like contra touching, because somehow to help eliminate the force. This is my first, I don't know how durable is it, maybe I will crack it. Okay, and now installation is almost done, because I think that it's sealed perfectly in that position. I just need to assume that what's gonna be the testing position. Okay, maybe if testing position is like this, can be no. Okay, we can leave like this testing position. So we can leave it like it is, I think. We don't need to make any specific thing. Okay, just a little bit to be aligned. I like when the things are aligned. Okay, now there is another thing that, oh, it's water or what it was? Yes, probably it's, yes, it's just water. So now, I forgotten to check if it's closed. We have on off. Okay, we have on off here, and we need to make it off, and I will use just, no, now it's opened, and now it's off. So because I'm going to put the water inside right now, and if it's not in off position, it could be a little bit really problem. So now I'm going to pour the water. I will use now I will use not hot water but cold water, in order not to dissolve more material like it is, because now there is dissolving of the material or cleaning is not the aim. The aim is to put something what can be very stable. So Okay, I will put a little bit of water. I'm not sure. Okay, I will put maybe much more water, because then I will tap a little bit outside, in order not to have air here, but to be sure that there is no air, there is just water, because we need to test the valve against the water. Water has different viscosity, or different viscosity as the air. So then I will just tap off somehow like this. I'm not sure if it's visible. A little bit, yes, it's visible. Okay. Second tapping, so I tap out a little bit of water. So now we need to create the same enclosure system for this cup, and basically it will be very similar thing. We just need a little bit more of this rope, but not so much, just a little bit more. Maybe this one could be enough. Let's see. And I would like to show you one trick. You can combine it, because it is like material. It can be a little, you see that it can be very easily combined by this way. Then we can use, okay, now my trick doesn't work somehow. Okay, every time when I'm in front of camera my tricks are not working. It's like intentional thing. Okay. We are a little bit strengthen it by carefully copying and trying to like mount it. Then it's much closer to the thread. Okay. And finally we need to put a little bit here, a little bit here, a little bit point here, a little bit point here. Okay, a little bit. Oh, no, this was the wrong direction. Mistake. Okay. Now the final tape. Okay. I contaminated again. You don't need to put so much tape. I just hope that the thread is not very deep, because then, okay, but it is quite deep. But I think that because every thread is a little bit conical, so if there is resistance, I think that the validity, anti-leakage validity would be okay. Oh my god, what I did. Okay, maybe like this way. I need to use against the table, because otherwise I will fall over the table. Effect. I feel that it's gonna be good. This is more than enough. Yeah, and now we have water inside. We know that water is okay. The water is also in the tub, but it's okay. I hope that this is not no. Okay, I hope that this is not the quality that the water is. This was just residuum of water. Yes, it could be just residuum, hopefully, because otherwise we will have water stream here. Never mind. I just need to, I just want to change the position. I'm a little bit blocked with otherwise because I just modified the table. Currently it's under modification. Okay. Because I need both of the devices here at one time. Come on. Perfect. Perfect. Okay, we can put it a little bit like that direction, and I hope that. Okay, I will bring hand the compressor and I'll be back in a minute. Okay, and the last step of the testing is that we will put the air, and I need to reset up the camera a little bit like this way. Maybe it will be fiasco, we will see, so I'll be very careful. Okay, but now I would like to change this 3.5 into, okay, here is 3.5, but we will start with 0.5 bar. Okay, come on. No, it's not automatic, it's just manual. 0.5, 0.6, okay, 0.6 is okay. Just to see that there is no fake this well, and nothing will be just peeing outside immediately. So not to put very high pressure. Okay, looks that nothing happened. Okay, but I need to be very careful because, okay, because here is water, and this is what I didn't realize, that it is not a good idea to have water in this let's say system, because we can damage the compressor. So I need, anyway, for testing reason, I need to reset up this thing like temporarily, like to be in, it could be in this angle way. Okay, it could be like in this angle way. Okay, so is it possible to capture both of? Yes, it is possible, but not from this distance. Okay, maybe here, and so I will just increase, because I see that, but it's still looking like to be some leakage. Oh no, oh no, oh no. This is not stable position. Okay, now here is stable position. So it's off. We will see, maybe it was just a residuum of water. I will just increase now dramatically to 2 bars, but 2 bars is still not absolutely not proofable, not enough. Okay, what I did, but I will switch on. Okay, just now I will improve to 3 bars or 3.5 bars. Okay, perfect. So now we have the system we have pressurized to 3.5 bars. It looks that there is no any leakage from our let's say our joints. I just want to pull out the water from the compressor because I'm not very happy with this water inside the compressor. And now we could see that there is no evidence of big leakages. I'm not sure if it's, but 3.5 bar is still not enough. Even if my house is connected to 3 bars pressure, but this is like it wouldn't be nice when the valve is valve edge pressure is 3 bars, because it should be 10 bars, and I hope in 15 bars. And be prepared that we can really damage the valve if it's fake, if it's just plastic material, because I don't know what's inside the valve. And in order to let's say mitigate the explosion, I will just do this way. Don't be surprised, but it can mitigate dramatically if there is any explosion. And I have experience with explosions, because in my hand 2 years ago exploded a pressure bottle. Okay, and I would like just to put camera a little bit, because my camera is also my mobile phone. Then I would like to save my mobile phone and also save myself. This we can, okay, this we can prepare like in that way. And now we will try to find, okay, what is this, 8 bars? No, this is for 4 balls. You don't see. Let's say this motorcycle. Motorcycle has no more. Okay, and what about this car? This car allows only 445. Okay, 445 is still not enough, but we can pressurize by 445. Okay, now there is pressure 445. Also, this valve can flow up. It's very I need to find where I can generate more pressure. Okay, maybe here. Maybe what is this pressure? I don't know. But this pressure is in another units, like US or British units, and this is PSI, and I have to check how much PSI is. For instance, 10 bar, it's 120 PSI. Okay, so this was too big. So 10 bars, but I'm not sure if this can survive. I have to apply safety glasses for sure, and also gloves. At least I can help a little bit. If some eruption occurs. So now I have, oh my gosh, I have 120 psi, and I'm going to install okay, I put off accidentally because I had worries. Okay, one more time. It's 112 psi. Okay. Now it's 120 psi. 122 psi. Okay. I will increase 100. Okay, 30 psi. Is it visible? Because it's important. Now it's 130 psi, and I can increase. Okay, but I need to check. Okay, now I will reinstall. Okay. Now I need to check that how much psi is around 108. Yes, 60 or 80. I'm blind. 12 bars would be enough, and it's 180 around. It's a little bit more than 12 bars. 120 psi. 180. Sorry, 180 psi. So we can try to, let's say, reach 10 bars. Okay. Now there is, okay, we have only 55 psi. There is some loss, but I don't know where is the loss. Maybe directly in that valve. Okay, now is 130. Okay, we can go up to 150. Now it's 150. Still stable everything. We can go to 160. Now it's 160, but I see that, oh no, this valve is going jump outside, so be careful. Not with that hand. I need to release because the problem is the valve. The problem is here because it is just the valve which there is rubber, and I'm not sure if this open, how big is this open. If this open is that on the bottom of this rubber valve is the plate, but if it can go, if the plate is smaller than the valve, it can go outside. But we can check the situation here because it is stable. Okay, and I don't think so any leakage here, but but maybe there is no leakage because of, okay, because of there is no, you know what I mean. What we have to do, we have to reset up a little bit this testing bench. We need to put the water inside, because now there is very probably that there is no water. If there is no water, there will be just air bubble coming from one direction to another direction. Now it's dropping the water. Yes, now it's dropping. I have real evidence that there is dropping the water. I will do it like this way. Okay, and I will repeat the compression experiment to 150 or 160 basically, but with, I just need to have camera some handy. This is also not good that I'm in front of this. Okay, this is not good. This camera position now must go somewhere here. Okay, because we would never be. So it's still persisting, and now there is important. I hope that there is water. How can I find it? I don't know. Maybe I can try to do it like this way. Okay. Yes, there is water, there is coming water outside. But we are losing the pressure somewhere, but we can be sure that here is water. If the losses are here, we should observe the water dropping, water leakage at least. I don't know if it's visible. So I will repeat the test. It's interesting that here is now it's 160, but yes, it's stable because it is not changing the value. As the value is fixed or indexed, there is no dynamic value, so there is even, let's see, but loss wasn't so big. There is no more than 160. Maybe it's so small capsule. Okay. What to tell? My final conclusion is that these valves are really durable. So, hello. I have to comment this part of the video externally because I made a mistake. I set up slow motion on my mobile phone, so I had to multiply the speed of the video, but it wasn't possible because I'm just using free Clipchamp, and it wasn't possible there to multiply the audio track, or basically audio track didn't like to be synchronized with the video. So finally I detached the video tracks in both of the parts of the video, and I will just say some commentary. Currently there is another testing where I'm explaining that the first test proved that the veil is durable when it's closed, but now there is a theory that when the veil is opened, then the pressure is spreading to the shaft for controlling the veil, and there is very high vulnerability on pressure between shaft and the leading part of the veil. Okay, and now I'm explaining that how I'm going to prepare the veil to be tested in open form. Usually there is very simple preparation. It is just necessary to close the open or the outgoing part of the veil by a small cap, but I didn't find any small cap, so I'm going to use a little bit specific approach, as you will see in a while. But currently I'm explaining that what happens when the valve is opened and there is no outtake. This situation, yes, and here is the preparation tool. Basically, it's another valve which is used for gas. This gas valve is very perfect for this purpose because it's one class better quality, maybe two classes better quality. It's really top quality because gas is explosive, or CNG is explosive, let's say, gas, and therefore it must be 100% reliability. So I'm going to install this gas valve in its closed position, and this gas valve would have the same function like I install any kind of cap, because this is only a half-inch diameter what I found technically. Now I'm explaining that there is flange system because I found many half-inch fittings but with no flange at the bottom, and there must be, because the terminating of the tested valve is also the valve is terminated by a flange, and there must be flange to flange, and between the flanges there is sealing material. This is not rubber material because rubber is not suitable for such extreme torques. Usually it's a little bit chewed, like chewing gum, because it's basically gum, and this material is much more durable for extreme pressures. To prove the pressure, I need to install this enclosure with very high quality manner. So now I'm installing and maybe a little bit resetting the camera to be focused better on the valve only, because now we know that the rest of the testing system is sealed perfectly. There are no any leakages or something like this, and I just need to install this extra valve. Yes, and I need to tie it off. I had to be careful in tying it off because the termination part is basically welded on the body of the tested valve. There is very nice welding, but anyway, it's still welding, and welding is or can be fragile on torque moments much easier than if there is all body made from brass material. But this valve looks very robust and very reliable. And now I'm slowly opening because I didn't know that everything is if everything is installed and if the shaft. Yes, here I'm just commenting that I'm trying to check if there is any dropping over the shaft and leading hole. And now I'm going to pressurize the system because there are certain losses. I think that during night, because this was today morning, basically the next morning after the whole night testing in closed position. So I need to pressurize it again. Yes, now we have 112 was the starting 112 psi, that was the starting pressure, and now I'm pressurizing to the maximum pressure, what is 160 psi, as you could see. And I will try to overpressurize as much as possible because there is still certain dropping in first threshold. There is no kept 160, and there is a little bit, the compressor is working again when I switch it on. So I just really wanted to get from compressor maximum pressure, and it is almost 160 because 160 is threshold, but this threshold, if it's achieved, and because it's opened, certain pressure comes back to the cylinder, so it is not like that it stops exactly on 160. So now I'm trying to move with the shuffle of the valve or needle, but I think that it's more suitable to call it shuffle, and it's working easily. And also why I'm trying to move it from on to off and from off to on position, that sometimes the moving can cause certain, let's say, water penetration, because under extreme pressures we have currently around 160 psi, what is basically around 12 bars. I think that usually the testing is performed on 10 bars, and we have 12 bars. I'm going to check the pressure now. It's a little bit, yes, I'm a little bit out of the camera. Okay, but I found this and I'm just screwing in. Yes, there you see that only 129 was the pressure there, but okay, now I'm not sure if it's working, the compressor. Yes, basically it's working. So I let the compressor working before installing the interface because it's much better. There are no dropping down situations. Otherwise, because of in the hose of the compressor there is atmospheric pressure only, and when I install and open the needle of the pneumatic valve, there will be big dropping, and even more the water could come inside the compressor. This is maybe more important reason why I'm trying to mounting the interface, pneumatic interface, in running position of the compressor, because when compressor is running, it is still pushing out the air, so it doesn't allow so easily to penetrate the water inside the compressor. So, and I'm testing again, And to be honest, through all the testing, there was no any drop, no any evidence of the leakage. And now I'm a little bit declinating the position in order to come to water inside this testing well, because so finally I have proved that the whales are really very high quality. Thank you very much for watching the video, and I hope that in spite of this disaster, you can enjoy or you can extract some useful information for your home projects. Thank you very much and see you in my next video. Bye bye.